Now see here, next one is here a photodiode. See here, it is also a specially designed diode. See here, in photodiode what happens here, suppose if you have taken here like this is the p-n junction diode, this is the depletion region, this is p side, this is n side. It is connected with here in the reverse bias and external load is connected here. Now when energy or the photons are allowed to fall on this transparent window, and this energy of the photon, that is E is equal to h nu, is greater than energy gap of this diode, then electron hole pair generation takes place at the junction. These electron hole pairs which are generated, electron and holes, electrons connected to the n side and holes are connected to this side because of the electric field at the junction. So electrons are going to the n side, holes are going to the p side, and when an external load is connected here, the current flows. And see here, this is the reverse bias, the current is here reverse, and when light is falling on this, the change in the current easily can be observed in the reverse bias. Or you can say here simply the current in this case reverse bias is directly proportional to the intensity of light falling on the diode. And its characteristics can be drawn like this thing is here, it is V here, it is I here, it is like that, in this way you will be getting, and the saturated current we are obtaining here. After some time current becomes saturated. And now one important property is here, these type of the diode can be used as a switching off or switching on the circuit, and also for the photo detection, and also for detecting the or for the demodulation here processes. So these diode has got many applications because they can be switched off or switched on very easily, and there is even a small change in the light flux can be seen in the form of the current.